Welcome folks. Today I'll be talking a little bit about an ignition coil. This particular one here is an oil-filled ignition coil out of a mid-70s 360 cubic inch Dodge engine. The reason I've got this one for a sample, actually, I had to take it out of service because up here on the part here, I'll just give you a quick demo here. What happened is this one is mounted just like you see in your video here. It was horizontally mounted, not up and down as per usual like this. I was checking connections and things, and I took the high tension lead out that leads to the center distributor cap. And when I pulled it out, there was some oil leaking out of the end of this tower here. And the thing I'd like to warn you about too is I'm not sure what kind of oil. They have oil in these things to keep them cool, I guess, because they develop heat because there's two really long coils wrapped in there. Thing with what I remember about some transformer oils and things is they had a thing that they called PCBs in them, and it's cancer causing. So if you ever, not sure just what kind of oil they would put in these things, but just don't be touching it with your skin just in case it contains those PCBs. Like I say, it's cancer causing. Just in case. Don't want anybody getting sick. Okay. What I'm about to do here is show you how to measure the resistance of both the primary coil and the secondary coil. Okay, and I've got a meter off to the side I'll be bringing into the video frame in a few seconds here, but just want to give you the lowdown on this thing. This is typical of, say, General Motors. This is actually a Chrysler product. Okay. But they use these ones in General Motors cars, your Chevys, even your Fords. Chevys and GM products went up to about 1974 when they used to use the points, breaker points contacts set inside the distributor cap there on the distributor itself. And then in 75 they went to the high energy ignition and they went to the coil and the cap model. But this was typical of the older cars. Not too special. You just got to keep an eye on them. The connections are clean, and this particular one, you don't want it leaking oil. You know, if it was a vertically mounted one in this orientation like you see on your screen, then it probably wouldn't have leaked, and you probably could have got away with just keep using it. But since it's a horizontal mount this way, it started to leak. So naturally, you wouldn't want to use that, because once enough oil leaked out of there, I'm sure that it would lose its cooling ability or whatever it does inside that canister there, and the coils would probably overheat and probably fry or do something and stop working altogether. Okay, so what I'll show you here is so I've taken some masking tape and cut out some plus and minuses on there to show you that there's a difference in the connections there. This is the positive terminal. This one had a transistorized ignition that was mounted on the firewall of the car. If it was General Motors, you would generally probably have two wires coming here. One battery supply for starting, and then when you release the ignition key to the run position, there'd be a resistance wire here to cut down on the voltage so it didn't overheat. So on the minus side, if you had the breaker style contacts in your distributor, that's all it would do, is this would go to ground, and inside a distributor it would just basically have your contacts and open and close it to complete the circuit on the primary side. Okay, so that's just the basic functioning of ignition coil. And there's two coils wrapped up inside here. The gauge of wire might be different between the two, but when you're increasing voltage, like the input side of this is 12 volts DC, battery voltage in your car, just as an approximation. And the step-up windings, there's a coil within a coil, so to speak, and probably a carbon core inside that as well. And it's the turns ratio of the wires in there. Okay, on the primary side, say you had this one's going to have many more, but just for an example, say you had 100 turns of wire on the primary coil, and then you wanted to step it up so you'd have many more. You do the math, simple math, and the output of this thing, you know, if the spark plugs required that much voltage, it can put out probably about 25,000 30,000 volts from 12 volts. So it's basically a step up thing. I don't know if I'd call it a transformer, but it steps the voltage up so it can jump the gap in your spark plugs to create the spark to fire the fuel air mixture in your engine cylinders. So what this video is really about, give you a little bit of extra there, and it's about how to measure the thing to see if it's good or bad. Assuming this one wasn't leaking, I just wanted to check it and put it back into service if it checked out. So I'll just bring the the meter into the fold here. And to steady things up, I'm going to put this ignition coil mounted in my little drill press vise here to steady things up so it doesn't go taking off on us here. Center it up. Straighten it up too, I guess. Alright, here we go. Okay, what you see is a multimeter here on the left, this big yellow thing. And there's different scales on here for volts, duty cycle, dwell, if you had the ignition points that you wanted to adjust, and it has RPM or tachometer on it, tach for short. And if you had this one particular one, there's some extra probes you could get for it to even tell you temperature to a certain extent. DC amps. There's a diode checker here as well. It's got a little audible alarm there to see if the diode's making the connection in the one direction. But the scale we'll be interested in today, actually I'll go a little bit close on the video to show you, if I can hold it still enough that is. This is the range that we're looking for on the meter here. It's these green figures here on the right between my thumb and index finger. And you start down here at the lowest part, which is 200, up to 200 ohms, 0 to 200. Then the next range, as you click this dial, will be showing you when I click this up to find the different ranges depending on what the measurement is that we have to find. And it goes up larger as you click up here, as you turn the indicator here to lock in that circuit on the test meter. So on the low side we'll probably be going around the 200 ohms, 0 to 200 ohms, because it's going to be a low reading. It's going to be according to, I got some specifications out of a few books there and just sort of averaged it out. And for the low side we'll be going about 1.4 ohms. Ohms are a measure of resistance. I'm not going to get too scientific at this point in this video about that. But there you see it has the word ohm, O-H-M, and just above it looks like a horseshoe. And that's the sign omega, I believe, and that's a symbol for ohms. So if you ever see that in electrical books or electronic circuitry or anywhere, that's what ohms are, a measure of resistance. Okay, so I'll just set this down here, and I should mention this too. These connectors here, they screw off, and then you've just got a plain steel probe. But some of you just starting out there, I might as well show you here now while I'm doing it. A little block of wood here. There's a reptile on both ends of these, if you have the clip screwed on, that is, and they're called alligator clips. And you can see there, and there's how they got their name. It looks just like alligator jaws there. You see that? So these things, you can clamp them onto something to free up your hands to move things around or make adjustments or whatever. Or if you have to use the probe, these things just screw off, and then you got a plain tip in there, much like a nail, small nail. Okay, there's our alligator clips. So what we're going to do is polarize this now. With ohms, when you're reading resistance, it's not too fussy if you go opposite way, but in North America, meaning mostly Canada and the United States of America, red just means positive or plus, and the black would be your negative or ground to your car chassis. Some of the older cars and maybe some of the imports in the old days might have had a positive ground on their chassis, but most cars that you see nowadays, they'll all be negative ground or minus sign. Okay, so what we'll do is we'll just keep it in good practice. We'll keep the black with the negative and the plus or the red. Okay, positive. I just put these two on here like so. There's screw threads and there's nuts underneath there, but I'm on the screw threads. They're brass pins with threads on them. And when you connect something like this, give it a good wiggle so that the metal can sort of grind itself there. If it's oily, you have to clean it first, but if it's dull or oxidized, that's what you do here, is rub them a little bit and get them to grind in there and get a good connection. Okay, now I'll go over to the meter now, and I'll start on the low scale of the ohms here. Take it right down to the 200, and we are getting a reading. Now if you go in the wrong range or too high, you'll notice that the decimal point, it doesn't really give you too much of anything to go on. And if you go up higher again, you see you start hitting zeros, and sometimes it'll just register a 1 and not move at all. So go down to that lowest range, because I know it's probably going to be the one we're looking for. That's from the 0 to 200 ohm range. Now we're getting 1.9. Now the thing I have to remember, I should have showed you this too, is whenever you're using resistance, some of the old analog meters with the moving dial, you had to calibrate them with a knob. So what you do there when you're doing ohms for resistance is there's actually resistance in these long wires as well. as well as the meter itself might not be calibrated to 0. This particular one, I don't think you can move it, but we can do some simple math to get a more accurate reading. So I connect those two together, and you notice on the meter there it says decimal 3 or 0.3. So that's either the meter out of the 0 calibration and or the resistance in these wires as well. So the reading we'll be getting off of this coil, we'll subtract decimal 3 off it, because this could put us out of range to say that this coil is acceptable for use. Okay, so now we'll go back to what I was just doing here now. We'll just reconnect. Remember the minus sign is the black or negative, positive or plus sign is red. Let's grind them in there again, go to connection, we're getting 1.9. Now I was just showing you when I connected those two alligator clips together on these test leads. It was showing decimal 3, so now we have to subtract that from the 1.9, so that gives us 1.6 or 1.6. Now the thing I got written off to the side here, just for a reference, is 1.4 up to as high as 1.8. So now we've done the math, we're down to 1.6 because of that extra 0.3 that the meter was giving us because of the wires or the meter itself. So it's really 1.6. So we're right between 1.4 and 1.8, and that's the primary coil that we're measuring there. It's the one with the lesser number of turns, and it's usually copper wire inside there, wound many times. Okay, that takes care of that, and that's the primary side of the coil. It checks out, it's good to go. But there's also another measurement we have to take into consideration, and that's the high voltage end, or the secondary part of that coil. Now to do that, now with the primaries, you go on, is basically connecting these two to get the low range, and then to get the secondary coil, or the high reading, we can take either one of these and measure between there and there like that, or we can go there or there like that. It doesn't matter. They make their connection with either one, so it's not fussy, but I'll just leave it the way it was before. I'll leave the negative on the black, just to give you some basic electricity or electronics here. And to get in there, rather than trying to fight this insulator that's on this alligator clip, is I've got a nail. It's a 2 1/4 inch common nail that you use around your house. Took a piece of 100 grit sandpaper and shined it up a bit so there wouldn't be any rust or anything that was going to make a bad connection. So I'm going to open up the old alligator jaws here, and it's going to grab a hold. I'm going to put it right inside there, so you see it's nice and secure. Like I say, you rub it around in there a little bit to shine it up and make sure that there's nothing going to cause a bad reading. So give it a wiggle, let it grind itself in there. Now we'll go into the secondary side, right into the part where the high tension lead would plug in. This plugs right in there, and then the rest of this wire, it actually goes into, like I said, your distributor cap, and then from there it gets distributed through the rotor into the different spark plugs in your engine. Okay, so now what we're measuring is from one primary terminal, it doesn't matter which one, and into the secondary tower here, where the high voltage comes out to the distributor. Okay, so now we're getting a reading of 1, and like I'd mentioned before, it doesn't really register anything. It's just telling me it's sort of sitting there waiting for us to do something else with it so it can tell us what's going on. Okay, so I'll take it up one range. That's from 0 to 200 ohms. Now we'll go into 2K. Now what K is an abbreviation for 1,000. So if it says 2K, that's 2,000. Okay, so we'll bump it up one notch there. Still getting a 1, so it's still out of range. It's much higher than 2,000 ohms. Okay, actually I should help it here just to make sure it's making a good connection. I'll put some pressure on it, but I tried it earlier and didn't need the pressure. Bump it up another one, 20K, so that's 20,000. Well, we're getting a reading now, so we must be getting close. But I'll go one more. I'll go up to 200K, which is 200,000 ohms. You can still get that reading, but it doesn't give you more spots past the right of the decimal. So I'll back it up to where it was giving us the best reading. Okay, so I'll tell you just before we get this reading here and explain a little bit about the decimal. On the high range, what I came up with, looking at a few different specs or specifications, anywhere between 8,000 and 12,000 ohms would tell me that this coil is operational, providing it didn't have the oil leak. Okay, so now we're showing 10.50. Okay, what I like to do here is my way of thinking, and it makes it kind of weird. You're looking at that, you're talking about 10,000 ohms. Well, it doesn't look like any 10,000 to me. So what I figured out a while back was take that decimal and think in terms of money. Okay, I'm going to take that decimal and put a comma there instead. Okay, and I'm going to add a 0 on the back, on the right hand side of this row of digits that are showing in the meter. So now it's 10,500. Okay, it's a lot easier to do it that way. That's the way I think about things when I you know, instead of going 10.5, I think, geez, what's 10.5? Doesn't make any sense. And then you have to look at the range. But I know that it's somewhere between 0 or 2K and 20K, or 2,000 and 20,000 ohms. Okay, so by putting a comma there and adding that 0, then what does it look like? Let's think in terms of money. No matter where you live in the world, we're talking about dollars, yen, marks, euros, doesn't matter. Rubles, take your pick. But anyways, if that's comma and a 0, then it's easy to understand. 10,500. Okay, 10,500 is about in the middle of the range that I gave you that it was acceptable for the secondary reading on this ohm meter, being between 8,000 and 12,000 ohms, so right in the middle. So this coil, as far as the two coils that we're measuring here on the primary coil and the secondary coil, or the high tension lead that comes out, they both check out. We can go back to that other one. We can go back to 200. We can put this back on. I'll even show you here, but don't do this. Get in the habit of putting it on the right polarity, because there are things you can mess up, like diodes and alternators and whatnot. You start, you know, putting power through it. This won't hurt anything, but you still get 1.9 there. Like I say, always put your, if it's the way it works in your country, if it's different where you live in the world, by all means use what's local. Okay, but for around here, so there we get that 1.9. Remember, we have to subtract 3. Also, with that other high number, it's so high it wouldn't make much of a difference, but you could subtract the 0.3 out of there and it would still be within that range that that I was telling you on the high side there. So 1.9 minus 3 is 1.6, and that's right halfway between the 1.4 and the 1.8 ohms that I had mentioned for the low reading on the coil. Okay, so I hope that helps you out in understanding how these things are measured and checked out. If it's leaking oil, like I say, don't get it on your skin. There's no telling if it is contaminated with that PCB stuff. I kind of doubt it, but it's better to be safe than sorry. Okay, so there you have it for today, folks. That's how you measure the primary resistance and the secondary resistance in an ignition coil that's the oil-filled kind. Another video I'll be doing in the future will show you the high energy ignition coil that's built into the top of a General Motors distributor cap, and it doesn't have oil, it just uses epoxy, kind of a glue, to bind all the coils together. So this is the oil-filled one anyway, so you have to differentiate it. And also, if you're testing a coil that's on your particular car, no matter if it's a Honda, Toyota, you have to look up the specifications. And a factory manual is a good place, or if you could find a dealership that will give you those numbers if you're having trouble, or somewhere on the net might have those specifications. Just make sure you get the right ones, and then check the primary and secondary resistance. Ohm meters don't cost that much. When I bought this one, I used to have an analog one, which I might even get out in the future and show you a comparison. The digital ones are more accurate, and you don't have to fuss with them too much to get your reading. This one was about $85 a few years back when I bought it. Probably cheaper now, maybe. Okay, there's your oil-filled coil resistance checking, both the primary and secondary side. Hope you enjoyed it. Take care, have a nice day, and bye for now.